Okay, so anyone who's into Jujutsu Kaisen knows about Maharaga, right? The divine general, this thing that's basically designed to be unbeatable because it just adapts. But what if I told you that power isn't really magic? It's actually a blueprint for a real-world algorithm that's out there right now tackling some of our biggest problems.
Yeah, everyone just says he adapts. But, that's kind of like saying a car drives. It doesn't really tell you anything about the engine, right? So from an engineering perspective, adaptation isn't just a word. It's a whole process. It has inputs, it has outputs, it has rules. The real question is, what's actually going on under the hood when that big wheel above his head starts to spin?
All right, let's really get into it. For a minute, let's forget about cursed energy and think like engineers. We're going to treat this whole ability like a piece of tech we're trying to reverse engineer. So what are the rules? What can we actually observe about how this thing works?
And what's wild is that the rules are super consistent. First off, Maharaga doesn't just adapt to, say, gravity just by standing there. He needs an input, an attack. And here's the really important part. He adapts to the whole concept of the attack. Not just one specific move, but the idea of slashing itself. That wheel turns, something processes, and boom, a perfect counter pops out. This isn't just magic randomness. It's a cold, hard, analytical process.
And that brings us to the first huge piece of the puzzle. Every single time Maharaga gets hit, he's not just taking damage. Think about it. He's collecting data. Every attack is just another piece of information being fed into his system. I mean, that's the absolute first step in any kind of learning, right? Whether you're learning to ride a bike or an AI is learning to spot patterns.
Okay, and this is where it gets really cool. This is where fantasy crashes right into reality. Because this whole process, taking in data, chewing on it for a bit, and spitting out the perfect answer, it has a direct parallel in the world of computer science. And it has a name. It's called a genetic algorithm.
I mean, just look at this comparison. It's almost a one-to-one match. For Maharaga, the problem is getting hit with some crazy attack. For an algorithm, it's just an objective it needs to solve. When Maharaga's wheel turns, that's like an algorithm churning through thousands, maybe millions of possible solutions. They call them generations. And the output? Maharaga gets a perfect counter, and the algorithm gets an optimal solution. It's literally the same logic, just, one's in an anime and the other's running on a server somewhere.
So you see this diagram and you might think, okay, someone drew up a blueprint for how Maharaga works. But that's not what this is. This is the real deal. This is the actual flowchart for a genetic algorithm. This is the engineering tool that basically simulates evolution to solve problems that seem impossible.
So, what is a genetic algorithm? Well, think of it like digital survival of the fittest. Instead of a programmer trying to write one single perfect piece of code from scratch, which is super hard, the algorithm just throws a whole bunch of random potential solutions at the problem. It lets them compete, and then it takes the best ones, breeds them, combines them, tweaks them a little, and does it all over again, generation after generation, until the absolute best solution naturally rises to the top. Let's actually walk through how it works, step by step. First, you start with a bunch of random solutions. You can think of these as Maharaga's first totally clumsy attempts to block an attack. Then, you test them. You see how fit they are. Did they work at all? Step 3, you pick the best ones, the ones that did something right, and you let them reproduce. Next up is crossover, which is just mixing and matching parts from the successful parents to create new offspring. And then, the fifth and maybe most important step, mutation. You introduce tiny random changes to keep things fresh. You just run that loop over and over and over until, bam, you've got the perfect answer. Okay, we have to talk about that mutation step for a sec, because it's the secret ingredient. It's the magic. Without it, the algorithm would just keep combining ideas it already has, and it might get stuck on a solution that's just okay. Mutation is that random spark, that happy accident, that leads to a totally new idea no one saw coming. It's how Maharaga doesn't just block a slash, he suddenly creates a whole new type of energy to completely nullify it.
And look, this isn't just a fun little what-if game connecting an anime to some code. These exact principles, this genetic algorithm stuff, it's being used right now, today, to solve incredibly serious, real-world problems. We're talking everything from national defense to life-saving medicine.
Just think about it. You've got an air defense system that needs to counter a brand new type of missile it's never seen before. It needs to adapt on the fly. Or imagine a rescue robot in an earthquake zone, where the landscape is constantly shifting. It has to find a new best path second by second.
These algorithms are even used in medicine to figure out the best way to deliver drugs to fight a disease. In all these situations where things are unpredictable and the stakes are super high, these Maharaga-like algorithms are finding the answer, just like he does in a fight.
But wait, there's one more level to this. And this is where things get, honestly, a little mind-bending. So far, we've talked about an algorithm that adapts to a problem. But what if the algorithm could adapt itself? What if it could change its own process for adapting?
See, even with these super powerful algorithms, a human still has to set the rules at the beginning. Things like the mutation rate. How often should it try a totally random idea? If you set that rate too low, it gets stuck in a rut and never finds a breakthrough. But if you set it too high, it's just pure chaos and it never lands on a good answer. Getting that setting just right is a massive headache for engineers.
And that's where this idea of self-adaptation comes in. Just imagine if the algorithm's own settings, like that mutation rate, were also part of the stuff that's evolving. So the algorithm isn't just trying to solve the problem anymore, it's also evolving its own strategy for how to solve the problem. It's literally learning how to learn better as it goes.
So why does that matter? Because the payoff is huge. It means you can take a self-adapting AI, throw it at a problem where you don't even know the rules, and it can figure out the best way to tackle it, all by itself. We're talking a massive leap in power and flexibility. This is how you get to a system that could, in theory, adapt to absolutely anything, just like Maharaga.
And that really brings us to the big, final question, doesn't it? In the story, Maharaga is basically a weapon, a tool for destruction. But if we can build real-world systems that can adapt and improve themselves on this level, what should we aim them at? What are the biggest problems we should tell them to solve first? Curing diseases? Discovering new materials? Figuring out climate change? The potential here, it's just as massive and world-changing as the algorithm itself.